Oh, yeah! I'm too fast for the camera. Woo! Hey, everybody, Adam Savage here in my cave, and we're going to be talking about big, awesome tools today. I love banging on this channel about American manufacturing and what it means to me. But I'm not sure that we have really ever shown you guys exactly what it looks like in 2024. Well, recently, Husqvarna, longtime makers of chainsaws and zero-turn and robotic lawnmowers and a ton of other awesome stuff, invited me and the Tested team to their factory and North American design headquarters in the Carolinas. Their technicians and engineers gave us a behind-the-scenes tour of their incredible 2 million square foot production facility, and we got to watch the design, assembly, and fabrication of the Xcite zero-turn lawnmower. We also got a deep dive into the newest processes and techniques finding their way into American manufacturing. Every single one of these giant building-size, house-size machines is a metal stamping machine, and they make all the dimensional metal parts for the things here. I have never seen so many in one place.
So this is where it starts. We get the raw steel in from our supplier. We'll feed it through the oiler so it's lubricated.
Oh, okay, that's what that first thing does, put some oil on it.
Exactly. So
Oh, and you need oil on it because the stamping dies.
Correct. We don't want it to stretch. We don't want to, when we're pressing it down,
right.
We want to make sure that it spreads out evenly. We don't want the dye sticking on it, causing any surface damage or anything of that sort. We'll have it centered. We've got some robotic or timed actuators there. It'll center the steel to where we want it to be. The little arms will come up right there.
Yep.
And that'll locate it for our robot. The robot will pick it up and put it in the press.
Are these a set of multi-step operations where this one makes one stamp and then the same piece goes to another machine?
Exactly.
Okay.
So this it's an inline stamping. So you'll have sequences of what's being done to it. Some of the dies will form it, some of the dies will punch holes out of it, and some of the dies will make sure that the edges are folded or trimmed neatly so that we don't have any cutting issues for the safety of our operators.
And these machines can be multiply configured to do all of that.
Correct. So we can skip a machine if we need to. If we have a need for 5 presses, we can run 5. If we have a need for 4, we can run 4.
Wow.
So it gives us that flexibility.
All right. Can we move on to the next step?
Yes, sir.
So as these pieces of steel are coming through here, are you? I expect the speed is part by part, but like. Is there a certain minimum? Is like 500 parts a day moving through this line?
Depending on the configurations, we can run anywhere from 120 to 180 parts per hour.
Per hour?
Per hour. So this thing's flying through every 30 seconds, 20 seconds, 15 seconds, whatever the case may be for that one.
Right.
And without any robotic stops, any malfunctions, everything's running smoothly, we can reach those rates easily.
Can we go see these robot arms?
Yes, sir. What we're seeing here is we're doing a transfer. So it's taking it, transferring over here. Now, what we also do in this sequence here, and the reason why it's wide, is we'll hand transfer. So if we have a deck that's already formed by this process or by that process.
Oh, you just bring it in.
They mesh it up against each other and they'll transfer it. So this robot will hand it off to the other robot and it'll go to the next sequence.
So is this the final press in this line?
This is the final 2 presses.
Okay.
Or this is the 2 robots. So we have the capability to do a 2-stage transfer. So
yeah.
You'll see the right-hand one pick it up and
put
it as a finished product here. And then the left-hand robot will transfer it over to the right.
Oh, gotcha.
Yeah, so it's 2 presses in 1, essentially, for this operation.
That's really cool. I didn't realize that everything was a robot.
Oh, yes.
Dude. All right, so tell me what's going on here.
Okay. What we have here is this is our mid welders.
Okay.
And we have about 40 of them in here. They run 1 minute and 56 seconds per cycle time.
No way.
Yes. And the great thing about this, it's a 3-phase. So we're gonna start here, that we begin here, what it starts out with this pipe. So once they get finished welding here,
Yep.
they place it up on the slide. That's the pre-weld. It comes around on this side. And when he get ready for it, they're hanging up on here.
Yeah.
And it comes, it locks in the gauge here to make sure that we lock every point. That's phase 2. And then phase 3 is when they check everything.
Yeah.
And they pre-weld, mid-weld. They have check gauges to make sure that they have everything in the correct place.
They're so much faster at welding than I am.
Oh, you can try it. Now look, the guys on the other side, like you see.
Oh, they're doing it for real.
Yes. Take a look
So
over there.
are they adding where this might have missed, or are they doing welds that this can't get to?
They're cleaning it and making sure that, you know.
They're inspecting every weld.
Yes.
Got it. Right.
Yes.
So any little thing, they're making sure it's tight.
Yes, you want to take a look?
Yeah.
Come on.
Also, that smell. I never get tired of the smell of hot steel. Melissa, thank you so much.
Thank you, I appreciate it.
I really appreciate the education. Have a great day.
Thank you, you as well.
After the metal frames are shaped and welded together, the pieces travel along a conveyor to the powder coat room where they're given that distinctive and awesome Husqvarna orange. It is really one of my favorite colors. They can coat 8,000 parts per shift, and any unused material gets swept up, filtered, and reused for the next set of parts. They even let me try my hand at powder coating.
Just that. All right. It's our logo. You guys.
Okay, now before we head to the assembly line to watch these mowers come together, I stopped to have a chat with Tim Morton. He's the head of global design for Husqvarna, and he walked me through the process of just how a product like the Xcite Zero Turn gets designed.
All right, Tim, I want to start with just asking you, what is ZTR? What does that stand for?
So ZTR means zero turn radius. It's a type of mower that was invented in the 40s. So it means that you can actually mow your lawn with no radius. Like on a tractor or a vehicle, you can have a wide radius.
Yeah.
This you can just pivot on a dime.
Oh, turn on a dime. So
Yeah.
it's not like it has a sharp turn radius, it's got no turn radius.
It's got pretty much no turn
Amazing.
radius.
And we were talking off camera. I was totally aware that this was a design prototype,
Yep.
but you said this is also a design prototype.
It is. Two very different prototypes, actually.
Yeah.
Now, the reason we prototype is to learn. We learn, we experiment, we test, we garner feedback, and really, hopefully we can fail early.
Right.
So these two are very different. This one, actually, we developed so we can learn how we put new technologies into a ZTR.
Okay.
So it's electrified. And when you electrify it, it opens up new opportunities of different interaction points and touch points. So we learned about the technology, we learned about the integration, we learned about the fact that, now we can have illumination because it's quieter and people can mow later on at night or in the morning.
Wow.
Yeah.
Where they never would before because they'd be mowing through someone's dinner time.
Yeah, exactly. Or waking them up in the morning. Yeah.
So, it doesn't take a stretch for me to understand that this is an engineering prototype.
Yeah.
I see the bare bent metal welded steel frame construction, and you can understand how things wear and tear like this. What's the reason to take this prototype all the way to what looks like final paint?
It does look final paint. I mean, there are parts in here that are fiberglass, printed, 3D printed, fabricated. So it's a mix-up of different parts to convey that story of what we could do.
Yeah. Yeah.
And to communicate to the industry and to our end users, this is possible in the future.
So this is like you take this to a trade show to show off what you guys have been working on.
Exactly. And it doesn't just stay there. We learn from that and take elements that are successful and put them into our future products.
Obviously, early on in the design process, you're dealing with bigger problems. And I'm assuming that as you sift, those problems get smaller, but harder. I'm
Yes.
curious about stuff you can learn from a all the way to final production look prototype that you can't learn from the engineering prototype.
Well, when you build something that looks, feels, smells, tastes real.
Yeah.
People get more convinced that it's real. So their evaluation levels change.
Oh,
So
fascinating.
you can get a finer detail on feedback from people. Does it feel right? Does it sound right? Does it look right? Is the stance okay? Is that proportion actually in line with the message that we're trying to get across? Well, this is very different.
Yeah. Can you walk me through how you guys execute your process here in the design center?
Absolutely, we can show you that. Whether you're designing a zero-turn mower, a robotic mower, or even a toolkit or toys, it's pretty much the same process.
Okay.
And we start with people, because we can create things, but if people don't resonate with that, then there's no point, right?
Sure.
So we start with people. We start to really understand what their needs, their desires, even down to values and behaviors and things that people don't talk about, but you can observe them.
So things that they might not know to articulate that they want out of a product, but that aligns with their values so that when they see that product, they are drawn towards it.
They're drawn to it, yeah, because we've got to understand, what do they value? We've got to understand what are their pain points, and like you said, they might not be able to articulate it, but we might see someone struggle or have a little bit of a pain with something. So we've got to understand that so we can make it usable and make it intuitive. Some of those weird emotional things come up, like people want to feel like they're having fun. So what does fun mean, right? We want to make sure that this is not a chore for them. So we design it in certain ways that evoke a little bit of fun. Absolutely within safety, and safety is the priority of it.
Right.
But sometimes when you're sat on a tractor, you might feel different to when you're sat on a ZTR, particularly this one.
Amazing. I hadn't thought about it as de-chorifying a chore, but that makes total sense.
Yeah. So we start to take that, and those hierarchy of things, of elements and benefits, we start to explore what they could be with industrial design and engineering. And they're hand in hand.
I was going to say that. Like, we talk about design and engineering as two separate things all the time, but they are absolutely inextricably linked.
Yeah.
You can't design something that can't be engineered. You can't engineer something unless you design it.
No, it's impossible, right? I mean, you're always going to come up against roadblocks, you're going to come up against problems if you don't partner and collaborate with those two teams together. And beyond those teams too, we're lucky internally we have manufacturing, so we can work with manufacturing to make sure what we're doing is viable and feasible. As well as sourcing and all the other business groups. Does it align to the business? Is it within price and cost and all those things? As well as the primary use of the end user. Is it something that they value and they use and they desire? So we can translate that.
We live in the age of user experience design, but I don't think people realize that mechanical things have to have a user experience design.
Absolutely, it's all user experience.
Yeah, exactly.
It's everything you touch, smell, see, hear, it's all an experience. And we try and design that experience to every single point. So on this particular one, we started to look at this adjustment. One of the team here, Eric, started to really dial in. And does this feel right as you pull it? Does it slot in?
How much force?
How much force?
Wow,
precision?
yeah.
Do we
So
need,
many little aspects for comfort.
Yeah, do we need 3? Do we need 4? So we started to dial that down. So if you look, it's a 3D printed part. We've got some machine parts from aluminum, or as I say, aluminium. And then we've got just the refined into spring until we start to really get it to a point. The second one, you'll see again, it's part 3D printed, bringing some brand design into this now. You'll
And
see
you had
this
solved,
element.
this is more of a solved problem at this point?
Getting close to solving
Yeah.
it. Not quite, because we went through multiple iterations, but you can see on that one, it slides pretty well.
Yeah.
And it actually got little holes
Yeah.
that have got a cone,
Oh, yeah,
so
so
it
they
feeds itself in there.
hard to get stuck
Do
between.
you need to do that? Probably not, but that is a great experience.
It's like the, it's a positive experience that
Yeah.
I'm not questioning what's going on.
Yeah, it finds its way, right?
Yeah. I mean, that's totally mission critical to the machines that we love.
Yeah.
Right?
We've got little tolerance for frustration these days.
Yes,
Because everything's so
yes.
accessible. So we got pretty close, and then you look at these parts. Now there's no more 3D printer parts. These are actually cast parts.
Yeah.
This actually might be a production or pre-production part, but it's cast parts. We're starting to bring in some labeling.
Extra
1
labeling,
through 4,
right.
plus, minus. We found that soft and firm was confusing. Maybe we just get to the basic. Is okay, you get a higher rating, you get a higher firmness, you get a lower rating, you get a lower firmness. And then really dialing this in a little bit more so it fits. And then, looking at some graphics very early on how we communicate smooth ride, how we communicate the benefits of it.
Talk to me about the difference between engine and electric zero turn radius machines.
So this one is designed for petrol, for gas, right?
Yeah.
Where obviously the electric is allowing for different things. So when you bring electric in, just like an electric vehicle, compared to a combustion engine, a lot of things disappear. Complexity disappears. Responsiveness increases.
Which is delightful from an engineering and design standpoint.
Yeah, and you can discover things that you couldn't do before, like the precision of control. You discover things that you
right. You don't have lag times. You don't have building up to your torque curve.
There's no, injection fuel there. There's no clutch, whatever it is that's going on there to make things work.
There must be times when you have to slow down the responsiveness of electric to at least be familiar.
I think we're on that road still,
Yeah.
where people are still responding, where maybe the first couple of experiences, it's a little too responsive.
Sure.
But we do and are looking at how we help people transition that on that.
Because it's going to be a whole different paradigm.
It is a very different experience, and it opens up lots of things.
So it looks like in the layout here of this design progression that it does move from design into the final steps are brand design.
Yes, yeah. If you look at the progression here, there's a combination of renders, and you look at when you put this next to the final product, you'll see how things have changed. We've discovered certain things about what I call value blocking.
Okay.
So you look at a product and you squint, and you might see different blocks. Like on this, you'll see the orange and you'll see the gray. Is there enough gray? Is there enough orange? So we balance that value. So you'll see the change there.
Right, and you do this from every angle.
Every angle. And we'll use technology so we can get into different angles too, very early on.
I particularly love the fact that you guys are, to a certain extent, exposing your framework here and showing the bent metal welded frame construction you're using, which I'm sure provides wonderful efficiencies for manufacturing, but also getting to see it makes, for me, the exposed design always feels like, I love looking at engineering, so it's something I find pleasurable. Is there a do-it-yourself aspect to people who would purchase one of these to mow their own lawns that you have surmised from some of these archetypes that lawn mowers like looking at engineering exposed?
We do see people hack things.
Sure.
Whether we support that or not, we support the spirit of that.
Yes.
And we actually can learn from that. It's like if people are hacking in things in certain ways, we can think, maybe that's important. Let's go look a little bit more. And
so when the customer is hacking one of your machines, your question is, what do they need that we're not delivering?
Exactly. And we can learn and say, well, is that valuable enough for us to start delivering it?
Amazing. Thank you so much. This has been such an education. I really appreciate it. So Venki, is this is the last step in the process?
Yes, but it's the first step to assemble things.
Okay.
So at this point, we get all the parts and they make it to home. We have things that they need to be. So we start putting our rails together.
Yeah.
We have the beginning process, we call it as a frame line.
Okay.
What we do there is we manage the rails with the transmission first and we secure them with the bolts. Okay. And then we manage the engine to that.
And they're doing this constantly. New ones are coming through constantly. Yeah. They're just doing the same action over and over.
So we build our residential zero turns here, and it's a high fast-paced environment.
Yeah.
And we have to be within that tack time and still be efficient and safe, and we have to make a quality product at the end of the day. So we have a new thing for us.
Yeah, I was wondering about this carousel here. This is really cool.
So it's a semi-automated line.
What, a semi-automatic line?
Yes, sir.
So does that mean that these are switching every set period of time?
Yes, but it has to understand by the operator. We want to keep our operator safe too.
Right.
So we want to communicate to the equipment that the operator is ready. So they have to hit the switch that I have done my operation.
Okay.
If you see,
and only when all the switches are done, it moves. Very cool. And this is, you guys are they assembling engines for this line, or are they assembling engines for another line?
Only for this line.
Okay, gotcha.
Yes. So we also have to be aware of the changeover.
Right.
So our teammates are very good. They're proactive and they stay ahead. So they make sure that they receive the right material.
Yeah.
And they feed the right material to the next process.
How long does it take to change this over from one engine to a different engine production?
So we make sure that there is a minimum impact.
Right.
On the engine side, we don't have a major changeover.
Yeah.
Meaning that we don't have a high time to change things. So it's a quick changeover. The main thing we have to keep in mind in a changeover is a setup time.
Gotcha.
So our MVs are very good. Our manufacturing engineers, they have done a fantastic job to design the fixtures that doesn't have to be changed. So it has a slots
Yeah.
that goes the engine plate at
Yeah.
different locations for the different models.
All right. So Venki, I think people think of assembly lines as rigid sets of instructions, but what I'm understanding from you is that it's really a moving process that is always evolving.
Yes, it's constant mindset to improve things.
Okay.
We don't want to sit and say that this is the final process and we have to stick to that. We always have a room of error or room of improvement.
So even at the end of a day, when you've delivered exactly as many parts as you wanted, you're still going to sit down and figure out, is there anything we could have done that made it better?
Yes.
Okay.
So the data speaks about it.
Yeah.
Every day at 7 o'clock, our team meets together and we discuss about the failures that we had yesterday. Even if the line ran at the production targets,
Yeah.
we still look at the opportunities that we want to improve.
And you want everyone to feel like they're pulling on the same rope, that they're
Yes.
working on the same team.
And everyone gets their ownership
Yeah.
and accountability to deliver that. And we have an amazing team that always does that on a daily basis.
And when anything's going wrong, anybody on this line who's working the line can stop it and fix that, be part of fixing that problem.
Yes.
Amazing.
They come together but at the end of the day, quality, maintenance, safety, and engineering comes together, and we see how we have to solve the problem, and we get the ideas together and we solve the problem.
Love it. This is so cool. Super awesome. It never stops. It never stops, never stopping. Even though it's really slow, it's inexorable. Once he is done attaching this strut, then the sticker goes on using a template. I love the sound of an impact wrench. All right, I think we're up. This is my big moment.
We just take one label and we make sure it's a regular ain't no air bubble.
All right. And, oh, okay, it lines on the bolts.
I hope I can.
That acceptable? Awesome. Thank you very much, man. Appreciate it.
Sticker jig.
Just to the, oh, okay.
That's it. No, yeah, go down. Okay, that's it. Okay, you just take the marker and just mark them. That way they'll know it's tight on the other end.
That means you've done all four.
Yeah, that's right.
All right, Venki, so from frame assembly to now, it's about, how long is it?
So it varies from unit to unit or model to model.
Yeah.
For the RZs that we build, we might run from frame line to here about 30 to 40 minutes.
Okay.
For the new model that we have, Riz, it takes around 50 to 60 minutes.
Okay, and this is the last step for
Yes.
this machine for shipping, is that right?
Not yet.
Okay.
In terms of the assembly, yes.
Yes.
That's the last step that we do.
So this is the last step for assembly?
Yes.
And what are these guys doing? Are they doing final quality checks and stuff?
They are setting the deck level at the right.
Making sure that it's perfectly level.
So after that, we're going to send it to the quality for testing and we
Gotcha.
package it.
I see. So quality has an operation they do with every piece
Yes.
before.
The 100% quality.
Amazing. Venki, thank you so much.
Thank you, Adam, for visiting us.
I have learned so much. I really appreciate it.
Thank you so much.
Okay, so Bryce, we just finished watching these things get fully assembled. Why are people still working on them?
Okay, so now that it's fully assembled, it's got to come through and go through our test cells. So we're going to verify that we've got a good unit. We're going to check the oil. We're going to make sure the neutral is properly set.
Right.
We've got a tracking adjustment, so that's making sure the right and left wheel are driving at the same speed. They've got a display up here that they're watching to measure that.
So there's a whole checklist of all these final things they want to make sure are perfect before this thing gets wrapped and packed in a box.
Yes, we want to make sure we have a quality unit. So
Right,
we
right,
start
right.
100% of them and run them through the test cell.
Now, when you're bringing in a new item, that's of course yields new entire checklists. How often after you've built a checklist do you need to add a new thing to it as a final check?
So that'll be product dependent. So if it's a product we ran before and that's
Sure.
already been developed, then we can just follow that procedure. But when new products come through, The engineering and operations design will all collaborate and determine what do we need to handle in the test cell to make sure we're shipping a quality product.
Amazing. So it's not very often that in the middle of like an established testing procedure, you add a new test.
Correct.
Okay. Correct. So once they leave here with all the, let's say this is great. I love this sound. After all these checks are done, it goes, I see it goes across this chasm.
Yep. So we'll push it out onto our pack floor.
Yeah.
Now we know we have a good unit, so we just have to put it in the crate, bag it up, and ship it.
All right, great. Can we walk its journey? Can we see its final destination?
Let's do it.
With the mowers packed for shipping, they are moved by an automated vehicle to await their destination. It is beautiful to watch. It's like a dance. But before I left, I couldn't resist jumping onto one of these mowers for myself to see what all the engineering adds up. I'm too fast for the camera. Woo. That is so much fun!